Hello and welcome to the Arduino course, the week 1. In this week, we will talk about the Arduino, the electronic concepts, and some programming concepts. In the first part, we will see some Arduino Uno overview. We will take a look over the IDE that we will use with the Arduino. We will see how to connect the Arduino with the PC. And we will also introduce the GPIO, General Purpose Input-Output pins. In the section of electronic concepts, we will see some electronic components and terms. We will also introduce the voltage divider. And lastly but not least, we will get to the programming part. First, we will see the LED circuit and programming the output, and then we will see a button circuit and programming the input, and eventually we will give you a small assignment to do. The learning objective of this week is to learn the Arduino parts and the pins, understand how the electronic components work together and what are their limitations, learn how to write a basic code, and build a circuit and control it with your code. The literature that we will use. First, there is the Discord channel. The link is here, you can click on it. And in this Discord channel, you will see some review of the code. We will see some projects. We will have a feedback about the sessions and other type of discussions. Next, please take notes during the class. This will be very much of a help to you. Also, you can take a look over the datasheet. And also you can find help online, the C programming language, and the tutorials of the Arduino. And please be careful when you Google something, don't take anything for granted. So, let's get started with the Arduino introduction. We have this board. This is the Arduino board. It has a chip on it. This chip is the microcontroller. This chip is the brain of this device, and this is the piece that you will be programming, and this will control the input and the output digital pins, which is right here. These pins will be connected to your digital input-output electronic components, and at the bottom here we have the analog inputs. Those will be also connected to your external electronic analog input devices or sensors. On the left side you will see the power. You can take a 3.3 volts or 5 volts from the Arduino itself to power your external electronic components. And of course, you have the GND at the bottom and at the top. You can see also there is a reset button. If for some reason you need to reset your program, you don't have to unplug the USB and re-plug it, but you can just press this button. And if you want to run your Arduino without connecting it to a PC, you can do that by plugging in the external power supply in this jack. You can download the IDE that we will use for programming from the link of the official Arduino website. This IDE, or Integrated Development Environment, this application will help you to write your code, and it will upload the code, compile it, and upload it to the target using the COM port, which will be connected through the USB. And you will also have to specify which serial port is your Arduino connected to. So when you need to upload your code, you have to configure the tool from Tools, Serial Port, and then choose the COM port that is corresponding to your Arduino. Next to that, there is in File, Examples. There are a lot of examples already made for you. You can use them. This is a Plink example, which will blink an LED. So after you click on the blink, you can either click the check mark to verify if the code is correct, or you can click the arrow button to upload the code to the Arduino. Now let's take a look over the GPIOs. So a GPIO is the general purpose input-output pin, and you can use those pins to connect either a sensor or an actuator. A sensor would be type of an input, and actuators would be a type of an output. And there is 14 digital input and 14 digital output. There is only 6 analog input pins, and those pins will be used to input an analog signal from an analog sensor. And please note, when you connect your sensors and your actuators, please don't use the pin 0 and pin 1. Those are the RX and the TX. Those are used to communicate between the Arduino and the PC. So those are reserved. A digital output pin is just like a battery with a software switch. So you can turn it on and off by using your code, and the output of that pin will be either high or low. And also the digital input pins are also the same. So you can either input low signal as 0 volt or high as 5 volt. And in your software, you must specify if the pin is an input or an output, only the pins that you are willing to use. Is there any question? Now the second section is about the electronic concepts. Electronic components and terms. Take a look at this simple example of controlling an LED. On the right side, you would see the components and how they connect to each other, and on the left side, you would see their representation in a diagram. So here we have connected an LED with a resistor, and both of them are connected to the pins of the Arduino. So it will take the GND from the Arduino itself, and the power will come out of the output pin. This is also known as a voltage divider. When you have a resistor and another part which also has a resistance, those are considered to be a voltage divider. And we use a resistor with an LED or other types of components to protect the Arduino from the component being withdrawing a lot of current. So in this way, we limit the current that the component is drawing from the Arduino, because the maximum amount of current that you can draw from a pin of the Arduino is 40 milliamps. So what is the amps or ampere? The ampere is the unit of current, and V or volts is the unit for voltage. Ohm is the unit for resistance, and here we also used D to represent the LED. So what is the current, the voltage, and the resistance? The current is the rate of flow of electric charge that passed a point of region. In other words, how much this piece of component is drawing energy from your power source. The voltage is the potential difference. So here in this example, we have a ground as 0 and a plus as 5 volts. So the voltage here is 5 volts. In your homes, it could be either 110 volt, or if you are in Europe or other parts in the world, there is also 220 volts. And lastly, the resistance. So what is the resistance? The resistance is an electrical quantity that measures how the device or the material reduces the electrical flow. So if we make an analogy of water in pipes, the resistance is bigger when the pipes is thinner, so the water flow is decreased. Let's take a look over this simple piece of component, which is an LED. What it does is it converts the energy into lights. It is considered to be a diode, which is one-way street of current, meaning you can't use it backwards. If you use it in the correct direction, there is no resistance, or almost no resistance. And if you use it in the wrong direction, it will be of high resistance, and potentially it will blow up. To find the positive and the negative of the sides of the LED, the long side is the positive and the short side is the negative. And if you look at it from the top, you can see that the bigger dash right here is the negative and the smaller dash is the positive. Also, there is a flat side. The flat side indicates that this is the side of the negative. Now let's take a look at the breadboard. This is just a piece of electrical component that we will use to hook up other electrical components to it. This is very useful. The top parts are horizontally connected to each other, and the bottom parts as well. The middle parts are vertically connected to each other, and they are separated with this line. So if you connect anything in this dot, for example, it is also connected to all of those dots or pins, but it is separated from those. If you connect a 5 volts to this pin right here, it will be also connected to all of those pins horizontally. We can use this for our advantage to have the GND connected to the breadboard, and then connect your parts directly to that row of GNDs. And also you can connect your resistors and your LED using those vertical lines. You should not connect the same component on the vertical row. You should be connecting the component horizontally on the vertical rows, because otherwise then you would be connecting the 2 pins of that component to each other, and then you can't use it. This is the button that we mostly use. It's just a switch. Those 2 legs are connected to each other, and those 2 legs also are connected to each other. When you click that button, the 4 of those legs will be connected to each other. When you release, then those 2 parts or 2 circles will be separated apart. So we can also take that to our advantage to simply read when a button is pressed. And of course you need to connect that button with a resistor. The resistor that we use with the button is a 10k ohm, and the resistor that we use with an LED is 470 ohm. You can connect the resistor in this way, and you can take one of those pins and connect it to the input pin of your Arduino. This is also a way of voltage dividing, because you have a resistor and you have another part of a component, and you are connecting both of them to your Arduino. But those types of buttons will generate false signals when transitioning from open to close and from close to open due to a mechanical construction. So at this bottom line right here is the signal when the button is not pressed, and here when the button is pressed, and this section is when the button is being pressed. And you can see it here more clearly that the Arduino will read 1 as a signal input that is high. High means it is pressed, or there is voltage on that pin. So you can read that the pin is pressed as long as you are reading ones, and then you can read the zeros when the button is not pressed. This is just a low input. Low is 0. And in the between those two, when the buttons start to bounce, you would read just a bunch of random inputs and highs and lows. This happens because your CPU is too fast, it's faster than the button itself, and you need a special type of trick to mitigate from this of being happening. Is there any question? Now let's get to the programming part. Let's program the LED circuit and program the output. So here we have a small piece of program, but what does it do? First, we have the global area where you would define your constants, your variables, and your types. Then you would have the function or the initialization part. This method is being run only once, so all of those codes inside those two curly braces would be run once when you start up your Arduino. And lastly, you would have this method or this function. This loop is being repeated as long as your Arduino has power to it. So at this line, you can see that we are configuring the digital input and output by using the pin mode, and pay attention to the capital and the small letters. First, we are defining in the two parentheses what pin we are going to define, and in the second part, separated by comma, we say if that pin is going to be used as an output or is it going to be used as an input. You need to do this only once in the setup. And of course, semicolons at the end, because this uses semicolons unlike Python. In the loop section, we read and we write to the pins. So here we are writing to the pin of that LED. We are writing a digital signal, so we are saying digital write, and also pay attention to the capital and the small letters. And in between the two parentheses, we are defining which pin we are writing to and what are we writing to that pin. So if we write high, all capitals, high mean I want that pin to have a high signal or have a 5 volts output. And if we write a digital low signal, low as all in capitals, then we are writing 0 volts to that pin. So this part means that I want to turn the LED on, and this part means that I want to turn the LED off. And here we have a delay which will make the program wait for 1,000 milliseconds before it goes right back up and do the next line of instructions. And of course, you can take a look at the references in the Arduino website. At the top is your global area where you will define the constants, the variables, and the types. The variable is like this one. We define it with the data type at the beginning, and then we give it a name, and then after the equal sign we give it the initial value, which is just an optional. A variable means that I want to reserve a piece of memory to read and write to it in my program. But a constant means I want to reserve that part of the memory for read only, because I won't be changing that value. Using this one is better if you are defining the bins that you are connecting your components to. So you would have variables to control the behavior of your application, but you'll also need to define where your components are connected to on your board, and for that it's better to use a constant. For the data type, we have integer, int, and this means that this variable will have a whole numbers. We have also a string type. A string means this variable will have characters, digits, symbols, or anything in between two quotation marks. And we have also bool. Bool means the variable will have the value of true or false. And we have long, double, decimal. Those three variables types means that the value of this variable will have decimals. So you can either have a whole number or a decimal with that number. Let's take a look at the button circuit and how to program an input. So at the top here we have defined a constant. This constant is being used to define what pin is the LED is connected to. And we have defined another constant which is defining where the button is connected to. In the setup method, we have configured the pin of the LED to be an output, and we have configured the pin of the button to be as an input using the input keyword. In the loop section, we are defining a local variable called val of the type integer. So this variable is local, and each time this loop ends and go backs up, this variable will be erased from the memory and created again. So the value of this variable will be lost. But we can still use it during a single loop. So we define it right here, we can use it right here, and when we reach this end of the scope, then that variable is deleted and we cannot use it in this run anymore. When the program goes up back again, it will define it again, it will reserve that variable in the memory again. Then also those instructions will be using that variable just fine. So we have defined this local variable and we are assigning the value that we are reading from the button using the digital read keyword, and in between the two parentheses we are giving which pin we are going to read from. So we are reading from the button, and the value of that we are storing in the local variable. This value would be either 1 or 0 because a digital output or a digital input can only handle 1 or 0, high or low. And we are setting an LED or that LED in that pin using the digital write. We are writing to that bin, and here we are writing the value that we have read from the button. So this means that first it will read the button. If it's high, then it will write to the LED high, which means it will turn it on. If the button is low or it's not pressed, this means that the LED will turn off. For the button bouncing problem, take a look online for solutions and try them yourself, see what are the differences and which one is the best for you. And lastly, we have the assignment or the practice. This is very much going to help you with your learning curve. If you do it, then you are way ahead of your colleagues. What I need is a piece of program that will run a vault. And you can demonstrate and test that code using the online free simulation website that I will show you in the demo. And also if you have the components, the hardware, that would be even better. So what is the assignment? I want to make a vault. I want to enter 4 digits to unlock the door. If the digits are correct, the door will unlock. If the digits are not correct, then the program will stop for 1 second and then it will take the new input again. for the next trial. So what you need is first, in installing the IDE environment, you need an LED digital control. So make an LED as a red LED to demonstrate that the vault is closed, and a green LED to demonstrate that the vault is open. And when you open that vault, make it last only for 10 seconds. So it will be open for 10 seconds and then it will automatically close back again. And you would need also buttons to represent the numbers. And of course, maybe you want to add an OK button. So you press the 4 buttons of numbers or digits and then press OK. That's up to you. And hopefully we can see it next time we run this event, or you can show it to us on Discord channel. Is there any question before we go to the demo and see how all of this works together, and also introduce the online simulation tool? Okay, let's go to the demo. So this is the website. It's called Tinkercard, and you can sign up for free. After you log in, you would see here on the left side there is circuits. Click on circuits. You can create a new circuit. Press on this button. It will take you to the simulation board. On the right hand side, you can look for the components. So I will look for Uno as an Arduino Uno. You can see that there is already a button example and a blink LED example. I will take the blink. So what we have here is that the LED is connected to the GND on the negative side, on the cathode, and on the positive side, which is a little bit curved. You can take a look at the LED separately if you like. The anode, this is connected to the resistor and eventually to the pin. And of course you can connect the resistor either on this side or this side, it doesn't really matter. And now for the coding. If you click on the top part, you can see the code button. Click on it. You can either use the blocks if you like, but I prefer not to, because the code or the text, it will allow you to have more control over your program. So click on this drop down menu and choose text, press continue, and you see that this program is almost exactly like the one we have seen in our slides. I will copy the code from our slides that I have already explained, and I will replace this one with that one. So this is the code from my slides that you already have seen. We have defined the pin number 13 because we are connecting the LED to the pin 13, and we are saying this is an output. We want to give it a voltage, we don't want to read from it anything, and we say write either high or low. Let's start the simulation. At the top here you can see start simulation, and now you can see that the LED is blinking. 1 second on and 1 second off. And of course you can change the color of the LED and play around. And you can choose the resistor and how much the resistance is. It's better to use 470 ohms with an LED. This way you protect the LED from being fried. Now let's take a look at the button. Now I will first connect a breadboard. just add a breadboard. Remove these lines for now. I will connect my GND to the negative side. Those are connected all to each other. When you hover over one of it, the rest are green, which indicates to you that those all are connected to each other. So if I connect this one to negative, now all of those already have negative. And those are connected to each other as vertical lines, and those as well. So I will connect my resistor, but don't connect it like this vertically, because now I am connecting both of the terminals to each other, and this means that the resistor is not going to be used. But you can rotate it from the button right here at the top left. There is rotate, and there is redo, undo, and delete. So I connect it right here. I will add also the LED, and I don't need to explicitly connect both of those like this. And now I need to connect the other part of the LED to the negative. So I will take this one and connect it directly to the negative. And of course I still need the 13, which is going to be connected to this part right here. And you can change the color of those lines by clicking on them. Let's first test if everything works. Okay. Now let's add the button and make, when I press the button, the LED turns on. When I remove or when I release the button, the LED turns off. For that, I need to go here and search for button. I take the push button, and I will place it. So I will add the button to the breadboard. I will also need a resistor, but this time I will use a 10K resistor. And this resistor also should be horizontally. Click on the resistor, choose the kilo ohm, and choose 10. And now this side is going to be connected to the pin that we are going to read from, which is pin number 2. So I will take this terminal and connect it to pin number 2, and this terminal will need to be connected to the GND, and we usually make the GND black. And the other part, which is right here, we need to connect this one to the positive, and as the positive is always red. And eventually we need to connect the positive from this terminal to the 5 volts that comes out of the Arduino. So we give the button a power using the GND and the 5 volts, and we read from that button using the pin number 2. Now, all we need to do is to add the code that we had in our slides. So let me copy that code real quick, and I will come here and replace all of this code with the code that we have discussed earlier. Let's run the simulation and see what is going on. Let me zoom in. Now, if I press the button, click on it, now the LED lights on. If I release it, the LED turns off. Click, it goes on, release, it goes off. Now this simulation is already slow enough that you can't really see the problem of the bouncing of the button. But in real life, if you try to make this in real hardware, you will have the problem. And that's why I advise you to look for a solution for it, and then we can discuss it next time. That's it for today. Thank you so much for being here, and I wish you a very nice day.